Chapter 3, Section 7 today. The title of this chapter in the book is Solving Systems of Equations Using Cramer's Rule. That's dealing with matrices. What I'm going to do is I'm going to call a little bit of an audible, and I'm going to teach you in 3.7 just how to solve using matrix operations. So I'm not going to teach you this thing called Cramer's Rule. So if you see solve a system using Cramer's Rule, do it the way that I'm teaching you today in the notes. But the first thing that I am going to do is teach you how to find a couple of easy things, matrix operations wise, in the calculator. Remember, if you need a little refresher on how to put matrices in the calculator, etc., there's a really good, in page 188, which is a page right before this section starts, kind of reminds you how to do that and make sure we're naming them, putting the dimensions of the matrix in right and everything. Okay, so I'm just going to jump into example 1, and it says evaluate the determinant. Now, the determinant for us, and the way that I'm going to teach you how to solve this, is not extremely important, but it's really easy to find, and it sets you up for, in a future math class, if you ever have to find determinant, here's how you do it. So here's what it says in example 1a, and I know it looks like absolute value bars, but this is the way they'll format whenever you're supposed to find the determinant. So it's not exactly like a matrix, but it is. It's still 2 by 2, but these kind of like absolute value bars mean go find the determinant. So here's how you do it. So we're going to go put this into this matrix in. Second matrix, if there's anything in your calculator, if you'll hit second plus 712, you'll get rid of it. Remember, when we enter matrices, we put them in edit, and this is simply 2 rows by 2 columns. So I'm going to do 2 by 2, all right, and go down and put those values in. 5, -4, 8, 9, double check, make sure it's in correctly. Again, the way that this is written, this is a matrix, just with the absolute value bars means find the determinant. So I'm going to quit. Here's how we find determinant. Go to your matrix menu, go to the math, and pick the very first thing, DET. So that's going to find the determinant of this. All the determinant is going to be is a number if it exists. So I'm going to hit determinant. I'm going to call up the matrix that I put in, and I'm going to hit enter, and we find that the determinant for this is 77. Not getting much why as to why we need that. You need the determinant if you're solving systems using Cramer's Rule, which we're not going to do it that way, but finding the determinant is really easy. It works the same way for 3 by 3 matrices, all right? So you can flip to page 190. I'll scoot it over so you can see it, all right? Just jumping into example 2. Now, they're doing it by hand in there, and we're not going to do it by hand, okay? So here's what it is. Again, it's a matrix, but they're using just kind of like absolute value lines. That means find the determinant. So here's a matrix. 4, -8, 3, -3, 2, 6, -4, 5, 9. Really, the only way you can get these wrong, since we're doing them in the calculator, is making sure, putting it in wrong. So make sure you put it in right. We'll be good. All right, so I can second plus 7. Oh, not that. Second quit. Second plus 7, 1, 2. Clear out the calculator. Go into your matrix menu. We're going to edit. All right, this is a 3 by 3 matrix. 3 rows by 3 columns. So hit edit, 3 by 3, and put it in. 4, -8, 3, -3, 2, 6, -4, 5, 9. Make sure you hit enter after that last one so that it inputs it in there. All right, there's our 3 by 3 matrix. I'm going to go to the home screen, so second quit. Go back into the matrix menu, second, that's the inverse button right here, that X to the -1. Tell it, go to math, pull up the determinant, and then go back into the matrix menu, pick determinant A. You can close a parenthesis for my OCD people out there. All right, hit enter, and we find that the determinant here is -93. Okay, so a determinant is just a value. It's going to be a number. There are times the determinant doesn't exist. If you get an error message, then you can just put no solution. All right, so how are we going to use the calculator to solve? Let's keep flipping in 3-7, all right? And we're going to go to example 4 on page 192. Again, I'm going to teach you how to solve systems using matrix operations. I'm not teaching you how to do Cramer's Rule. All right, so here's what we got. We've got a system of equations. 5x minus 6y equals 15. 3x plus 4y equals -29. All right, so that's what's going on. We've got 2 lines there in standard form. I mean, we could graph these in Desmos and get it out. Again, that's -29, a little bit hard to see up there as I look on the board. Okay, I'm just doing example 4 out of the book. So what we're going to do is we're going to go put these coefficients and these answers in two different matrices. All right, so I'm teaching you how to solve a system using matrix operations. Again, it's in Kramer's rule, so I'm just teaching you how to solve. We need to make two matrices. All right, here's what you need. Matrix A needs to be a coefficient matrix. Remember what a coefficient is. It's a number in front of, in this instance, an X or a Y. So it's going to be a 2 by 2. So 5, negative 6 is my top row. 3, 4 is my bottom row. See where I got the numbers from? 5 is in front of the X, negative 6 in front of Y, 3 is in front. So I got 2 rows by 2 columns. Keep in mind that's a 2 by 2 matrix. We're going to need that in a second. Okay? You're going to make a second matrix. Matrix B is going to be what your answers were, or what it was equal to, or math term, what those constants were. Okay? The top row is 15, the bottom row, negative 29. This is a 2 by 1 matrix. When you have just X and Y, or when you're solving only for 2 variables, this is how you'll set up matrices A and B. All right, so we need to go put those in the calculator. So I can second plus 7, 1, 2, clear out what's in there, go to my matrix menu, go to edit. I'm going to put matrix A is what matrix A was, a 2 by 2. Okay, and we'll put it in. I'll move it so you can see it. So 5, negative 6, 3, 4. All right. Again, just make sure it's in right. Make sure you're paying attention to the signs, not hard. All right, we're going to go back to the matrix menu. We're going to go to edit, and this time I'm going to put in matrix B as a 2 by 1. That's the answer, or the constants, and that was 15, negative 29. So they're both in there. Double check. We check this one, it's right. So here's the formula. This is a key. If you miss this, then you're going to get this wrong, and I don't want you to. All right, so you learned matrix multiplication in 3-6, and so it's the same deal. So here's the formula to find your missing values. Now, I put capital X because it's going to give it to you as a matrix. You take matrix A, you hit the inverse button, so it's going to look like it's got an exponent of negative 1, and you multiply it by matrix B. This is the formula for how you solve a system of equations using matrices. You've got to have this, get it written down, know how to do it. Here's what it looks like in the calculator. Okay? I'm doing the math now. So second matrix. I'm calling up matrix A, which was my 2 by 2. I am hitting the inverse button. That's above X squared. It's X to the negative 1. It's the same button you hit to get in the matrix menu. You're just not hitting second. So I have the inverse of matrix A, and I'm going to multiply that by matrix B. So it should look something like that. I'm going to hit enter, and look at this. You're like, huh, what's that? Okay. Well, when I did that right here, I get this, negative 3, negative 5. In the right order, the ordered pair answer, or the intersecting point of those two lines, the X is negative 3, the Y is negative 5. It puts it in order. Top one's X, bottom one is Y. Very, very simple to do using matrix operations. Here is the point where those two lines cross, okay? Really kind of a nice, neat trick to use. The nice thing about it, 2 by 2, you can still do in Desmos, but this is really good when you get to a 3 by 3 system. So I got one more. Page 193, example 5. Let's look at it, all right? Let me write it out. So we've got this system. Now I've got 4x plus 5y minus 6z equals negative 14. 3x minus 2y plus 7z equals 47. And 7x minus 6y minus 8z equals 15. Make sure your signs are right. Just kind of double check, because if we get a number wrong, then we're going to get the wrong answer. All right? So this is my 3 variable system. Now you know that it was a little bit complicated to set this up and solve by hand. Not hard, but you had to do elimination. You had to plug back in. Matrix operations will make your life a lot easier. So here's what we're doing. I need to go make a matrix A, and I need to go make a matrix B. Now this time, matrix A is going to be a 3 by 3 matrix. The reason I know that, we got 3 variables, okay? Let me kind of side note. If you're ever solving for 3 variables, and like right here, let's say that 4x wasn't there, and the top line just said 5y minus 6z, you would have to plug in 0 for x. So you have to have a placeholder for 9 spots in this matrix, in this 3 by 3 matrix. Luckily for us, we've got coefficients, so go fill it in. The top row is 4, 5, negative 6. I just followed my coefficients. The second row is 3, negative 2, 7. Again, I just followed my coefficients. The bottom row is 7, negative 6, negative 8. My bottom row of coefficients. Don't put the constants in there. Just put the coefficients, the numbers in front of the variables. All right, what matrix B is, in this instance, there are 3 answers. There's only going to be 1 column. So 3 rows by 1 column. Put them in. So I've got negative 14, 47, and 15 are my 3 answers. Now, when we go do our formula, x equals matrix A, I take the inverse of it, I multiply it by matrix B. So let's go put them in and see it. So second plus 7, 1, 2, clear them out. Plug in your matrix, go to edit. This time A is up 3 by 3. Make sure we put it in right. Oop, see, I didn't do it. 4, 5, negative 6 is my top row. 3, negative 2, 7 is my middle row. 7, negative 6, negative 8 is my bottom row. Just kind of give it a double check, make sure it's good. I think we're right. Second matrix, put in the constant matrix or the solution matrix. Matrix B is a 3 by 1. Remember, you got to know how to do dimensions. Negative 14, 47, and 15. Double check, make sure you hit enter. All right, they're good. They're all in. Go to the home screen. Call up matrix A. Hit the inverse button. That's x to the negative 1. Hit times. Call up matrix B. Second matrix, you can just pick number 2. There you go. Okay, it says that the matrix is this. 5, negative 2, 4. That's in order, X, Y, Z. Your ordered triple, 5, negative 2, 4. Much, much easier way to find ordered triples, okay? 2 by 2 matrix, maybe a little bit better in Desmos. 3 by 3 matrix, so easy to do in the calculator. Now you kind of know how to do it, and moving forward, you got a green light on however you need to solve it. Make sure you're getting this stuff written down. This is very, very valuable stuff and makes solving systems so much easier for you. All right. Again, if you have any questions, come talk to me.